Welcome to Statistics. My name is Dr. Twane. In today's econometric class, we are going to derive the normal equation for a simple linear model. In a simple linear model, we have just two variables, one dependent and one independent variable. And that's why we say two variable case. In our next video, we're also going to show you how to derive the normal equation for a multiple linear model, particularly the three variable case where you have one dependent and two independent variables. Now, in the two variable case, we have our y is equal to, let's say, beta 0 hat plus beta 1 hat x1 plus, let's say, u hat. Now, if we want to make this u the subject of the formula, it means that we're going to move all of this to the left-hand side. And if we do that, our y will be minus. Now, let's group this and call it beta 0 hat plus beta 1 hat x1. Now, the whole of this is already on the left-hand side. So what we are left with here is a u hat. You agree with me that if the whole of this is equal to u hat, then it implies that our u hat is equal to the whole of this, which is y minus all this beta 0 hat plus beta 1 hat x1. Now, let's give an illustration of what we have just done. When you're given a set of values for two variables, y and x, or let's say x1 and y1, and you have something like this. Say the values are scattered. We can call this a scatter plot of the data set. If we have the data like that, now the fitted line might be something like this. Call it y hat is equal to beta 0 hat plus beta 1 hat x1. Now, the reality here is that these are the fitted line, these are the observed values. So the difference between this fitted line, if we take this point, the difference between that point and then the fitted line is what we call our u hat. It's also the same as if we say the difference between, say, this point and this. We'll call this our u hat, and all other points. Now, so our u hat is equal to y minus y hat, where the y are the observed values. So it will, by extension, mean that our u hat is equal to y minus, what is our y hat? We already stated it here, which is what? Beta 0 hat plus beta 1 hat x1. And if you look at this and what we have here, you see that they are the same thing. So this is just an illustration of what we have done here. The next thing to do here is to do what? Sum the square of both sides. And if we are to sum the square of both sides, it means that we will have summation of u hat square is equal to, so we also have summation of the whole of this. So let's put it in bracket and say y minus beta 0 hat plus beta 1 hat x1. And then because we square the left-hand side, we're also going to square the right-hand side. Now you must note that our emphasis are on the parameters to be estimated, which is our beta 0 hat and beta 1 hat. So for that reason, we are going to differentiate this, which is known as the sum of square residual. So we are differentiating our sum of square residual with respect to each of the parameters to be estimated. So in the first case, we have the partial differentiation of sum of u hat square with respect to beta hat 0. And when we do that, if we differentiate this, it will give us minus 2 summation of our y minus, we have beta 0 hat plus beta 1 hat x1. Now, if you are wondering how we have this negative value, because sometimes students might just think you multiply this by this and that gives you the solution. No. What we have done here is to use what we call function of a function in this differentiation. Now, let's just take a little time to explain this differentiation for those who may not really understand how we have done this differentiation. But if you do, just give us a little time and we are going to continue from here. So we'll start by saying, let the whole of what we have here be equal to m. So we'll say, let m equal to, see what we have in the bracket, y minus beta hat plus beta 1 hat x1. And if we put the whole of this as m, it means that our sum of square residual will be equal to, that will mean that this will imply that our summation, our sum of square residual will be equal to, we have this summation of m, but the whole of this is raised to power 2. So it will be summation of m squared. Now if we are to differentiate this, it will mean that the differentiation of our u hat square with respect to m is equal to 2 summation m. Now, why is it so? In our differentiation, we multiply the power by the coefficient and reduce the power by 1. So 2 times 1, the coefficient here is 1. 2 times 1 will be 2. Then we have summation of m, which is this. Raised to power 2 minus 1 will be 1. So this is raised to power 1, but we don't need to write the 1. Now again, we're also going to differentiate m with respect to beta hat 0. So that will be the m, the beta 0 hat will be equal to minus 1. Now, note that everything in this bracket is affected by this minus. So minus times this will be minus beta 0 hat, and this will also be minus beta 1 hat x1. So that's why we have this minus. And again, if you have y is equal to minus x, our dy all over the x will be equal to, now the power of x here is 1. So we have 1 times, the coefficient of x is minus 1. Then this x is this. We know the power is 1 and we reduce the power by 1. So 1 times minus 1 is minus 1. This x is this. And then 1 minus 1 is 0. So minus 1, anything raised to power 0, of course, we know it's 1. So times 1. At the end of the day, minus 1 times 1 is minus 1. And that's why we have this minus 1. So that our partial differentiation of the sum of square residual with respect to beta 0 hat is equal to, now the formula is with respect to m times the m with respect to the beta hat 0. Now the whole of this is what we have estimated as, we differentiated as this. We have differentiated the whole of this as this. So this will be equal to 2 summation m times the whole of this is what we have as minus 1. So which will be equal to times minus 1. So if we multiply this by this, it will be, now have minus 2 summation m. But our m is equal to this. So in place of m, we are going to write this. So which will mean that we'll have minus 2 summation. Now our m, note that our m is y minus what? Beta 0 hat plus beta 1 hat x1. And that's what we differentiated and showed you here. So you now understand how we got this. In the same vein, our partial differentiation of the sum of square residual with respect to beta 1 hat is equal to minus 2 summation x and then y minus we have beta 0 hat plus beta 1 hat x1. Now, if you follow exactly what we have done here in this differentiation, you also see that this is correct. Because at this point here, at this point, we have got this, we have got this. At this point, the next thing we do is also differentiate m with respect to, that is differentiating this m with respect to beta 1. And if that's from here, if we differentiate m with respect to beta 1, now our dm, you see that our dm, the beta 1 will be equal to minus x1. Because we already agreed that this is minus beta 1 x1. And so when we differentiate that, the result will be minus x1. And if we do that, again, it will be that the summation u hat square with respect to the beta 1 will be equal to the summation u hat square with respect to m times the m with respect to beta 1 hat. All of this is what we had initially as 2 equal to 2 summation m. And then all of this is what we now have as minus x1. So if we have this, then it will mean, so multiplying this by this will be equal to minus 2 summation x1 m. But our m is equal to what we have here. So this will be minus 2 summation x1. Now our m is y minus beta 0 hat plus beta 1 hat x1. Okay? And if you look at this, you see that that's exactly what we have here. The next thing will be to set the whole of this equal to 0. So we'll say setting u hat square with respect to beta 0 equal to 0 and u hat square with respect to beta 1 hat equal to 0. It will mean that 0, it will imply that our 0 is equal to minus 2 summation of y minus beta 0 hat plus beta 1 x1 and then 0 again is equal to minus 2 summation of x into y minus beta 0 hat plus beta 1 hat x1. Now, if we do that, from this point, we can call this equation 1 and this is equation 2 because we are looking at it, we are handling it simultaneously. So, if we divide through by minus 2, then here we have 0 over minus 2 and the whole of this over minus 2. Now, minus 2 will cancel this minus 2. The same thing is applicable to the second model. 0 over minus 2 will still be 0. Minus 2 over minus 2. The whole of this over minus 2. Minus 2 will cancel it. So we'll be left with what? 0 will be equal to summation of y minus beta 0 hat plus beta 1 hat x1 and then 0 is equal to summation of x into y minus beta 0 hat plus beta 1 hat x1. Now the next thing is to open the bracket. And so 0 will be equal to, that's for this first line, 0 will be, remember that this is we're saying this is our equation 1, and this is equation 2. This is the continuation of equation 1, and this is equation 2. So from this equation 1, if we open this bracket, this is going to be, now when you say sum of y, in some books you see yi, but using some of this subscript can be confusing. So that's why I decided to work without the subscript. But our yi will be something of this nature. You have y with all the values. So you are summing over the values of y. And so this will be summation of y. Now minus, let's see, maintain this inner bracket. And so this is a constant. So if you are summing the constant, assume you have something like 5, and you are summing, let's say you have 5 like 3 times. If you are summing this, it will be 5 plus 5 plus 5. So, but when you write summation of 5, somehow it's better you say how many times does this 5 occur. And that's why we are going to say this, since it's a constant, we have n beta 0 hat plus, and now this will be beta 1 hat summation x1. Now, to open this other bracket, this is still continuation of equation 1. Now, to open this other bracket, we'll have this 0 is this, is equal to, this 0 is equal to, then we have summation x and y will be summation x y minus, let's still maintain the inner bracket and open it. So this is going to be beta 0 hat summation x, that is multiplying this and this, and y here will have plus beta 1 hat summation x1. Now x1 and times x1 is going to give us x1 squared. Note that this is x1. Okay? So this is the continuation of our equation 2. Okay? Now, the next thing is to move the whole of this to the left-hand side. And if we do that, then this negative sign is going to change to positive sign. And so we'll have n beta 0 hat is equal plus, because they are in the bracket, beta 1 hat x1 will be equal to, what we have here is a summation y. And then this other one will be beta 0 hat summation x1 plus beta 1 hat summation x1 square is equal to this. That's the whole of this is this other side. So what we have here is summation x y. So this is what we refer to as what? Our normal equation. So that's what we refer to our normal equation. So you might want to go a little further, and by that we can write this in matrix form. And in writing this in an augmented matrix, in writing this normal equation in an augmented matrix, we'll have n, that is n here, and then x summation x1 summation x1, and then this is summation x1 again, and then here we have summation x1 square. And so we have the parameters as beta 0 hat, and then beta 1 hat. So all of that will be equal to, now what we have here as the vector of constant is summation y and summation x1 y. So note that there's a summation sign here. Please, sorry about that. Okay, so once we do that, then it is easier for us to also be able to get the parameters, the direct formula for the parameters. From this normal equation, it's very simple for us to calculate the coefficients of the regression model, which is beta 0 and beta 1. But we can also go a step further to get the direct formula for the direct method. And that will mean that in the first place, we say let A be equal to all of what we have here, which is summation, n summation x1, summation x1, and summation x1 square. So that the determinant of A will be equal to, if we are taking the determinant of this, it will be equal to this time this minus this time this. So we'll have n summation x1 square minus summation x1 all square, which is this times this. Now the next thing to do is to use this vector of constant to replace the first column of this matrix. And if that happens, we'll have that our B will be equal to summation y. And the next one is summation x1 y. While we are left with this summation x1 and summation x1 square. So that the determinant of B will be equal to, now this time this minus this time this. I hope we are following. So which will be summation y summation x1 square minus summation x1 y. Now the next thing will be to use the vector of constant to replace the second column of this matrix, and we'll call that C. So C will be equal to, this remains as n summation x1, and then using this to replace this will be summation y summation x1 y. So that our determinant of C will be equal to this time this minus this time this. So we'll have n summation x1 y minus summation x1 summation y. Now, the general formula is that our beta 0 hat is equal to B, the determinant of B, all over the determinant of A. Which is equal to, look at our determinant of B here. So, and that's equal to summation of y summation x1 square minus summation x1 summation x1 y all over. Now, the determinant of A is n summation x1 square minus summation x1 all square. Also, our beta 1 hat is equal to the determinant of C all over the determinant of A. And what's the determinant of C? This is our determinant of C, which is n summation x1 y minus summation x1 summation y all over. What is our A? Our A is n summation x1 square minus summation x1 all square. So this becomes the formula for estimating the intercept, which is this particular intercept. While this is the formula for estimating the regression coefficient, our beta 1 hat, which is this particular one. So you see that from this point, you can just substitute the values that you are given, and you'll be able to get the values for beta 0 hat and this for the values for beta 1 hat. Or from the normal equation, you can just substitute and use the simultaneous equation method, whether the Cramer's rule like we have done here, or you are using the substitution method, elimination method, or any of the method, and you'll be able to calculate the regression coefficients. So that from there, you can give the interpretation of your results, and that will be it. Thank you. In case you have not subscribed to our channel, please, for us to do more of this for you, subscribe to our channel. Help us to share the videos to your friends and colleagues, those who are finding it difficult. We will do our best to simplify it. Like the video. God bless you. My name is Dr. Twane. Thank you.